If you can't blindly trust servers, admins, or even logs anymore, how do you prove what really happened in your systems? In this course, we'll design trust architectures that stay verifiable, auditable, and resilient in a post-AI, post-quantum world. For most of computing history, we trusted whoever ran the server and whatever sat behind the firewall. That model is collapsing. AI makes it cheap to impersonate anyone and to fabricate convincing logs, messages, even identities. At the same time, quantum computing threatens to break many of the cryptographic assumptions we rely on. Together, these forces push us from trusting by default to requiring verifiable cryptographic proof for every critical action. A trust architecture is the rule book that decides who is allowed to vouch for whom, and under what conditions. At its core, it connects three things: identity, authority, and governance. Identity is how we decide who or what an actor really is. Authority determines which actors are allowed to make statements or take actions. Others must accept. Governance covers what happens when things go wrong, get disputed, or need to change over time. Centralized trust is the model most of today's systems still use. One entity vouches for everyone else: the bank, the cloud provider, the government, your IT. When that authority is honest, resourced, and competent, you get great efficiency, clear governance, and someone you can sue when things go wrong. The downside is that you inherit their failure modes. Technically, there's a single point of failure or corruption. Organizationally, you're exposed to insider threats and policy changes you don't control. Strategically, an attacker only needs to decapitate that one hub to disrupt the entire ecosystem. Federated trust appears when multiple organizations form an alliance and agree to vouch for each other under shared rules. Think of payment networks, identity federations, or industry consortia. Each member keeps some autonomy but accepts common standards for identities, credentials, and dispute resolution. This buys you scalability and resilience. There's no single king, and the operational burden is shared. The trade-off is that governance becomes political and slow, and the federating gateways turn into powerful choke points. From a risk perspective, you now worry less about one rogue actor and more about collusion, cartel behavior, and sluggish reaction to new threats. Decentralized trust replaces a central authority with a shared protocol and cryptography. No single party is in charge. The rules and the math decide what counts as valid behavior. In return, you gain tamper-evident history, strong censorship resistance, and excellent auditability and resilience, especially against physical or organizational attacks. The cost shows up in complexity and overhead. Consensus, smart contracts, and governance mechanisms are computationally heavy and can introduce new classes of bugs and coordination risk. Traditional systems say trust the boss or the institution, an admin, a bank, a cloud provider. Blockchain-based systems try to replace that human or organizational trust with verifiable guarantees. Cryptography answers: was this data changed and who signed it? Consensus answers: what does the network agree actually happened? Transparency answers: can anyone independently verify that history without asking a privileged intermediary? Consider a medical diagnosis model built without any hospital ever shipping raw patient data. Each hospital trains locally and only shares gradient updates. Those updates are committed to a blockchain, so anyone can audit which version of the model used, which contributions, and when. On top of that, you issue tokens when sites provide high-quality, non-fraudulent data and slash rewards for detected manipulation. You've turned a black box AI into a transparent, incentive-aligned, verifiable collaboration. Think of centralized, federated, and decentralized designs as risk profiles, not ideologies. Centralized works when you trust a single operator, care about speed and efficiency, and mainly fear external attackers, not the platform itself. Federated fits when multiple institutions must collaborate, but no one wants to fully hand over control. You accept existing authorities yet want shared governance. Fully decentralized makes sense for low-trust environments where tamper evidence and censorship resistance are non-negotiable. Your task is to match your threat model and regulatory constraints to one of these profiles, then justify that risk trade-off. Trust decomposition means you stop asking one layer to do everything. At the top, you optimize for speed and UX. Compute, storage, and UI live in conventional cloud or data center stacks. They can scale, change frequently, and even fail without corrupting your root of trust. In the middle, identity is usually federated, OIDC providers, enterprise IAM, or DIDs. This layer answers who is acting and under what authorization. At the bottom, you anchor truth and settlement. A blockchain or similar immutable log records final commitments, disputes, and high-value events. Designed by asking which layer must be cryptographically unquestionable and which can remain merely trusted enough. Quantum risk isn't science fiction, it's a timing problem. We don't know exactly when large quantum computers will arrive, but once they do, today's RSA and elliptic curve protections fall quickly. The practical requirement is crypto agility, designing systems so their cryptography can be swapped out with minimal disruption. In practice, that means planning distinct upgrade paths for centralized services, federated identity, and decentralized smart contract ecosystems. The core shift is from implicit trust to verifiable trust, backed by cryptography, transparent protocols, and auditability. You now have a toolbox: centralized components for efficiency, federated layers for coordination, and decentralized ledgers when you need shared, tamper-evident truth. Aim for hybrid architectures, not purist blockchains, and start building in post-quantum and AI-aware defenses before you're forced to migrate under pressure.